We're going to talk about symmetry today. And what I have here is the function x to the fourth minus x squared in Desmos. And I have picked my exponents carefully because I want to have an example of an even function. I want to be able to take negative x in the place of x and do the very same thing that this function f of x equals x to the fourth minus x squared is doing, and show you that I indeed have the same thing, that it reflects across the y-axis. That means that when I basically it looks like the y-axis would be a mirror from one side to the other. And when I go and I put in f of x or negative x for f of x, watch what happens. I'll put in that one and bleed out the first one, and you can see that the function has not changed. It's the same graph. It looks different on paper. Now I have a negative x instead of an x, but you can see that because of the exponents being even, I really have not changed anything. Now let's go look, and this would be symmetric across the y-axis, and if you remember further on into our discussion on even and odd functions, this is an even function. The exponents are even. That's a good clue that you're going to have an even function, and sure enough, it reflects around the y-axis. F of negative x is equal to f of x. Again, here is f of x, and here is f of negative x. No change. Now I'm going to look at a function that reflects around the origin. This is the cubic 3 times x cubed minus x. And let's zoom in on it a little bit so you can see it's a very pretty function. And it rises, makes kind of a hump, and then it comes down through the origin, and then it does a very symmetric thing. And it looks to me that if we could rotate around the origin 180 degrees, we would have the very same graph. It's true because I now, in my next equation, I'm going to take, if number 3 is f of x, graph number 4 is going to be negative f of minus x. You can see that I've already, for my fourth graph, I've already put negative x in place of x, and I've put a minus sign around the whole thing. And sure enough, it's the same. So if negative f of negative x is equal to f of x, this is a function that rotates, or that is symmetric around the origin. It's not odd. It's not true that f of minus x, oh yes, it is odd. If you look at this, f of minus x is equal to negative f of x, but in fact I'll show you, no, let's not do that. Let's go on to functions that reflect across the x-axis. This is kind of hard to do because it's not often that f of x is equal to minus f of x. But I've found a relationship that's not really a function, but it certainly reflects really across both x and y axes. And when I put in, if I multiply through by a negative number, that will be somewhat like negative f of minus x, I get the very same circle. That's symmetry in a nutshell. Use Desmos to play with this, but really you're going to be needing to be good with the algebra, putting in x and minus x and showing me on paper that a function is even or odd. You'll have plenty of chance to practice it and have fun.